Okay, so we are talking about the equivalency between context free grammar and PDA. So today we will talk about the given a PDA which is accepting a language, we can construct a corresponding context free grammar. So then we will see the theorem which is tell us their equivalency. So the theorem is telling given a language L, which is a subset of this, we know sigma is the set of input alphabet, such that there exists a PDA push down automata M, which is we know q sigma delta q 0 z 0. We take the set of final state at phi, because we want to this is we are accepting in the term means of the empty stack. Then the such that there exists a PDA such that L is equal to n of m. So, n of n means set of all string. I mean this is the language accepted by this PDA in the sense of empty stack. That means, n of m we know n of m is the set of all string coming from sigma star such that we start with q 0 and z 0 this is the w is the TF. So, this is the initial ID 0. So, from this ID if we can go to the empty stack. So, there is no concept of final state over here. We go to some state, then we complete reading the TF, that means this W is exhaust, and we reach to a empty stack. So, that means we put this is our TF, this is say W A1 A2 AN, say W is of length n, and this is our starting state Q 0, this is Z 0, this is the first, this is the situation of the initial snapshot, initial ID. Now, if it is by we take the move of delta. So, then we go to some other state and it will keep on reading like this, and the stack symbol will replace. So, we know the delta is basically a function of q, we take a input alphabet, and z it will replace to, it is a non-deterministic move, some p and some gamma, this we have discussed. So, finally, if it is reaching to a situation that the stack is empty and we exhaust the reading this n. So, our tape is pointing here and this is our some state q. This is for some state q, for any q. I mean q belongs to, q is any state, we do not need to, here we have no concept of final state, because this is the acceptance by the means of empty stack. So, this is done. So, we have exhaust this, and now if the stack is also empty, nothing is there. So, this is empty. So, then we call this W is accepted. So, this search of all W's is the language accepted by the means of empty stack. So, now we will see we can construct a corresponding grammar which will accept this language by the means of this CFL, context free grammar, context CFG we can have. So, this is given, then one can construct, then we can construct, then there exists a, we can construct a context free grammar G, which is we know V T is here sigma, because sigma is the terminals or the input alphabet. Okay. And we have a starting symbol and we have P. P is the rules. We have a grammar, sorry, P is here, P comma S. S is the starting symbol. So, S belongs to V, such that the language generated by this grammar is same as L, which is same as N of M. Okay. Now, we will see the construction of such a grammar. So, from a given PDA, how we can construct such a grammar, that construction we will see. So, for that we need to define the symbols, variables. Terminals is same, that is the sigma, but variables we need to define. Okay, so, let us try to construct a grammar. So, we have given this Q sigma, this is the stack symbol, we have delta Q 0 Z 0 phi. Now, we defined a G, which is V, then sigma is our terminal string, terminal symbols, which is we are taking a sigma, then we have a P, we have S. S is the starting state. Okay. Now, V consists of S along with this type of tuple, 3 tuples like this, Q 0 is the starting state, Z 0 is the starting stack symbol, and the Q, and this is for all Q belongs to V 0. So, if we have say 2 states Q 0 Q 1, then what are the states? States are what are the variable? Variables are say S comma all these symbols. So, Z 0, or if we have say Z 0 Z 1, then we have Z 0 Q 0, all possibilities Q 0 Z 0 Q 1, Q 0, this Q 0 Z 0 is fixed over here, sorry, no, not Z 0 fixed. So, Z 0 will vary. So, Q sorry, no, this is not the, we have to vary this is the movement. So, we have to vary all possible states and the stack symbol. So, this is basically set of these 3 tuples Q, Z, P, where for all Z coming from the stack symbol and PQ are for all PQ coming from Q. So, all possibilities are there. So, if there are two states Q 0 Q 1 and if there are say 2 symbols Z 0 Z 1, then what is our V? V is S along with this all possibilities Q 0 Z 0 Q 0 Q 0 Z 1 Q 0, then we have Q 0 Z 0 Q 1. So, all the possible combinations of this coming from this. So, this is the way we define this. So, now how to construct the rules now, that you have to see. Okay. So, to construct the P, we will take S first, S production, this is called S productions. So, for S production we have these rules like this. So, S is going to Q 0 Z 0 P. This is for all P belongs to Q. Okay. This is for all P belongs to Q. So, this is so these two are fixed, these two are coming from this Q 0 Z 0 and P we are varying. So, this is the way we construct the S production. Now, we will see the other production, like we have that other production, this is the S production. Now, we will see the other productions. RS production will be coming from the transition functions. So, transition functions means, suppose we have a transition like this, delta of, we are at Q and A is the input symbol, Z is this. So, suppose this is having, say this is going to say some Q 1, Q 1, Z 1, Z 2, Z m, and there may be others also. So, that means, this Q 1, Z 1, Z 2, Z m is belongs to delta of Q comma A comma Z. So, this will yield some productions in the P. So, what are the production it will yield? It will yield the production like this. So, this Q we are fixing, this Q, and Z here we are fixing this Z, this Q is coming here, this Z we are fixing, and now we have a choice of this Q m plus 1. This is any state we can say, we have a choice of Q m plus 1. So, this is going to A, this A along with, so we start with Q 1, Q 1 we have no choice, this Q 1 will come here, Q 1, and then we have alternative Z 1, then we can take Q 2, we have a choice over here, followed by, these are the product, then Q 2 we have to take Z 2, then Q 3, Q 3 Z 3, Q 4 dot dot dot, then we have finally Q m. These are the choice, I mean these are all options, these are any states, this Q 2 is any state, but if this is Q 2, this has to be Q 2, then Q 3 also any state. So, then Q m, Z m and Q m plus 1, this Q m plus 1 and this Q m plus 1 are same like this. So, dot dot dot, these are the production we have. So, we have choice here, we can choose this for any So, we have choice here, we can choose these are fixed, this fixed, this is fixed and this one is fixed, these two are coming from these rules, this is Q, sorry, this is Q, this is A, this is comma and this is Q 1. So, Q 1, Z 1, this, and we have a choice over here. So, this we can choose, this belongs to Q for any. So, we have an option there, once this is fixed, this has to be fixed, then we can choose this, this is fixed. So, this way we can continue. So, these are the rules for the productions, these are the productions coming from this transition like this. Okay. So, this is clear. No? So, now we have to have, if this is having epsilon, I mean if this is erasing, then what will be the move. So, that we have to, if m is equal to 0, m is equal to 0 means nothing is there. So, this is going to epsilon. So, that we will see. So, let us see, this is rule 2. So, if m is equal to 0, that means, if Q q1 epsilon is belongs to delta of q comma a comma z. Okay. That means this z is erasing. We are erasing the z. We have to erase the symbol to get the empty stack. So, that we are doing. So, okay. So, for that what is the rule? So, as we take the q over here and then we have z and we take the q1. So, suppose this is going to q1, this is going to a. So, this will yield as a rule like this. This is going to a if it is erasing. So, q of z q1 is going to a, this a. q1 is this one, q1 is this one, this is q, this is q1 and this is z, this is our a. Okay. So, this is the construction. This is the construction of the grammar. So, if you construct the grammar in such a way, then we can prove that this will give us this will generate the language, which is because we are emptying this by taking the terminals. Terminals are coming from this input alphabet. So, let us take an example, then it will be more clear. So, let us take an example. So, consider a PDA which is having two state q0 q1 and say AB, this is our sigma, and we have z0 z, two variable in the stack, delta we have to define, q0 z0 5. Okay. This is the, and delta is given by this, delta of q0 b z0 is q0 z0. Then delta of q0 epsilon, there is epsilon move over here, z0, this will give us q0 epsilon. Then delta of q0 bz, this is nothing but q0 zz. Then delta of q0 az, this is nothing but q1, we have z will be remain as z, but it will change to q1. Now, let me complete this, delta of q1, once I write at q1 bz, it will give us q1 epsilon. Okay, it will erase the this z like this. Okay, so delta of q1 a z0, which will be q0 z0. Okay. So, this is the rules. So, now we need to convert this to a grammar. So, this is given PDA. Now, the corresponding grammar we know G is V, T is here A B, and we have P and S. So, basically we have to define S, I mean we have to define the V and S. So, as we said, T is given this and V is basically S along with all the tuple like this P, Z, Q, where P, Q are coming from the Q set of all possible states and Z is the input alphabet. So, if you do that, then the states are basically, I mean variables are basically this. So, q 0, z 0, q 0, then q 0, z, q 0, all the possibilities, then q 0, z 0, q 1 like this, all the possibilities. I am not writing all over, it is written in the lecture note. So, it is there. Now, we have to define the rules, the S rules and the others production. So, rules will be coming from here. So, let us write the rules. So, S rule, as you know, S rule is nothing but so S production. So, S production, as you know, it is just S is going to q 0, z 0, p, and p here it is varying. So, we have two states. So, it is give us basically S is going to q 0, z 0, q 0, q 0, or S is going to q 0, z 0, q 1. This is one rule. This is two rules. We have S is going to this, S is going to this. This is the S rule. Now, the other rules are coming from the transition. So, let us take this transition. So, we will see how this transition will convert. So, that means this belongs to that q 0, z 0 belongs to delta of q 0, b z 0. So, this will give us this rule. So, q 0, z 0, q 0 will go to all possibilities. The b is here, b of q 0, z q 0 along with q 0, z 0, q 0. Okay. So, this we have a choice. Here we do not have any choice. This we have a choice, and this we have a choice. So, once we fix this, this will be like this. So, this is one rule. So, another rule is, so we will vary this one. So, another rule is q 0, z 0, and this is q 0. So, we can vary this also. So, we can make this q 1. So, is going to be of q 0, this is z 0, sorry, this is earlier one, it was z, this, because z is the first one, z and q 1, then we have to take q 1 first, then z 0, q 0, because whatever the hover state over here, that will come here. And another two possibilities is we can take this as a q 1. So, this is q 0, z 0, q 1, this will go to b of q 0, z, yeah, we can take here also we have an option, we can take q 0, and then we can take, then we have to take q 0, then z 0, and then q 1. And another option is here we can take q 1. So, that is the q 0, z 0, q 1. Here also we can take q 1, b of q 0, z, q 1, then q 1, z 0, q 1. So, this is the rule corresponding to only these transactions. Okay. Similarly, we have to have the rules for all these transactions, then we will get the corresponding grammars, and we can see their equivalence, they are accepting the same language. So, this is the details of this is given in the lecture note, I am not writing all others. So, okay. So, they are basically equivalent. Now, we will have a theorem which is telling the equivalency between all of this PDF and CFL. Okay, so let us have this theorem. sorry. The following three statements are equivalent. First one is L is a CFL. L is n of M1, where M1 is a PDA. For some PDA M1, L is M of M2 for some PDA M2. Okay. So, we have just now we have seen which one, given a this one we can construct this. So, just now we have seen 2 to 1, and we know if a language is accepted by a PDA in the means of empty stack, it can be accepted by a PDA. I mean, we can construct the corresponding PDA which will accept by the means of final state. And we know given a CFL we can construct this. So, these are all equivalence basically 2, 3 are equivalent, then 3 to 1 like this. So, this we have already seen. Thank you.